Hello there, welcome to this video. This is 3-2 and we are talking the chain rule. We're going to go ahead and use the chain rule in a bigger sense and mix it in with some other derivative rules and properties that we have learned previously. So let's go ahead and dive to it. So previously we've worked with the product rule, the quotient rule, and the chain rule, but we worked with each of these separately. In this video and lesson, we're going to go ahead and do a couple of things. One, we're going to use the chain rule repeatedly. It's truly going to be one of those Russian nesting dolls where derivatives just keep popping out of each other. And then secondly, we're going to go ahead and use the chain rule with problems requiring product or chain rule, and maybe even the quotient rule. Okay, so let's go ahead and look at our case number 1, repeated use of the chain rule. Sometimes we need to repeat chain rule more than one time. And then hint, for trig functions, the angle of the function will never change. So example number 1, find the derivatives of the following functions. Here I have f of x is equal to sine squared of 3x. And it's important to know that when you're working with the sine squared functions, that really it's the trig function, sine of whatever the angle is, to the power of 2. So when we go ahead and differentiate here, we have the power rule first, 2 times the sine of 3x, okay? Now I have to go ahead and multiply times the derivative of the inside, the derivative of sine of 3x. Well, the derivative of sine is cosine. The angle does not change. And then I have something inside of that. I have a 3x inside of that. I can differentiate that. That's times 3. So there is our derivative. I had one derivative, and then another, and then another. Okay, it's just like peeling back layers of onion. Makes you want to cry. 6 sine of 3x times cosine of 3x. It's a happy cry though, right? Okay, there's our derivative. There's f prime. B, g of x is equal to e cosine of 2x. Okay, well this time I'm going to go ahead and take the derivative. I'm going to work from the outside in. The derivative of e is just itself. I have e to the power of cosine of 2x. And then now I have to take the derivative of the exponent, right, of my u, if I was to u sub that out. And then the derivative of cosine of 2x is a negative sine of 2x. And then I have to take the derivative of the inside of the trig function, which is 2 times 2 times 2. Okay, and then putting this all together, it looks like we have a negative 2 e to the power of cosine of 2x times sine of 2x. And I just shuffled terms. Nothing too major there, right? Multiplied the 2 with the negative. All right, example C. Here, I'm going to go ahead and rewrite that radical. So g of x is equal to x squared plus tan of 5x minus 1. And this is all to the power of 1/2. Okay, so the derivative, I'm first going to use the power rule. I'm going to bring down my 1/2. Inside remains unchanged. 1/2 of x squared plus tangent of 5x minus 1 raised to the power of negative 1/2. Okay, now I'm going to go ahead and I'm going to move inside. I'm going to take the derivative of each of these. So the derivative of, so this is multiplied times 2x plus the derivative of tangent, which is, let me put this in red, 2x plus the derivative of tangent now is secant squared of 5x minus 1. And I'm not done with the derivative of tangent because I have another function inside of this. The derivative of 5x minus 1 is a 5. And that only applies to the secant squared. The derivative of this inside has nothing to do with this 2x. Okay? So if I wanted to go ahead and rewrite this, let me put the 2 in the denominator with my negative exponent, that negative 1/2. That's going to go down into the denominator, so square root of x squared plus tangent of 5x minus 1. And then sorry. And then this portion is going to stay in the numerator, right? So we have 2x plus, and I'm just going to move that coefficient of a 5 in front. 5 secant squared of 5x minus 1. There's your derivative. There's g prime. Okay, so those three examples, we had one chain rule after another. And maybe not every term needs chain rule again, right? Like this x squared, it's just 2x. But tangent here, we did have to use chain rule again, okay? All right. The next examples, we're going to go ahead and utilize the chain rule with the product and the quotient rule. So example A, f of x is equal to x squared, hey, that's one function, times sine of 4x, that's another function. So f prime of x is equal to the derivative of the first, which is 2x, times the second, sine of 4x, plus the derivative of the second, we have cosine of 4x. But I have another function inside here, so I'm going to multiply times 4. Okay, multiplied times the first, which is an x squared. Okay, and if we wanted to go ahead and clean this up, 2x sine of 4x plus 4x squared cosine of 4x. All right, so there we go. B, g of x is equal to x squared times the square root of 4x minus 1. And I just like to right away rewrite this to the power of 1/2. I have one function here, and I have another function here. So I'm doing the product rule. Again, product rule. So g prime of x is equal to, okay, derivative of the first. So 2x times the second, square root of 4x minus 1, plus derivative of the second, okay, so I have 1/2 times 4x minus 1 to the power of negative 1/2 times the first, which is an x squared. Okay. Oh no, before the x squared, don't I have a derivative here on the inside? So I have a 4 that I got to multiply by now times the first. I almost forgot that. Okay, so I'll go ahead and clean this up. We have 2x square root of 4x minus 1 plus the 2 and the 4, they're going to reduce. I can reduce by 2, so I'll turn this into a 2. So in our numerator, we have 2x squared over the square root of 4x minus 1. Right? That negative 1/2, it moves it down into the denominator. So here is our derivative. All right, so that is the chain rule as well as the product rule being utilized together. Now we're going to go ahead and see some examples where we're dividing. So what rule do we have to use? That's right, the quotient rule. So we're going to go ahead and differentiate. Okay, so h prime of x is equal to, and with the quotient rule, I want the derivative of the top. So e to the power of 4x. Well, I also have to multiply times the derivative of u here, which is the 4. Okay, times the bottom. So sine of 2x. Okay, minus the derivative of the denominator. So that will be cosine of 2x multiplied times the derivative of the inside there, which is 2. So multiplied times 2, times the numerator, e to the power of 4x. And all of this is over sine of 2x squared. And just with trig notation, right, anytime we square a function, we put that power of 2 right there. Maybe I won't put it there for now. Maybe I'll do this. And then I'm going to go ahead and rewrite this. So we have 4e to the power of 4x sine of 2x. Minus 2e to the power of 4x cosine of 2x, all over sine squared 2x. If you were feeling really crazy, you could factor out a 2e to the power of 4x, but hey, We're not getting too crazy right now. There you go. All right, last example, D. I want to go ahead and I want to take the derivative here. I have k prime of x, and I'm going to take the derivative of the numerator. So I'm going to do power rule first. 3 times 3x minus 1, power of 2, times the derivative of the inside, which is a 3, okay, multiplied with the denominator, 2x plus 5 to the power of 4, okay, minus derivative of the denominator, 4 times 2x plus 5 to the power of 3, now times the derivative of the inside, which is 2, okay, I have that chain rule there, now times the numerator, which is 3x minus 1 to the power of 3, okay, all being divided by 2x plus 5 to the power of 4. Okay, and we'll go ahead and clean this up. 3 times 3 gives us 9 times 3x minus 1 squared times 2x plus 5 to the 4th minus 8. For the sake of consistency, I'll put this together, times 2x plus 5 cubed. Okay, and oh, I forgot, the denominator is squared, all over the bottom squared. So here we have power of a power, and this just gives us 2x plus 5 to the power of 8. All right. Alrighty. Make sure I didn't mess that up anywhere else. No. Okay. All right. And there you have it. You could reduce this. You could go ahead and reduce this if I had each of these separated. Let's say like so, over 2x plus 5 to the power of 8 minus 8, 3x minus 1 cubed, 2x plus 5 cubed, over 2x plus 5 to the power of 8. It looks like all of these would cancel. So this would give me 9 times 3x minus 1 squared divided by 2x plus 5 to the 4th minus, and then over here, 3 of these will cancel. So we have 3x minus 1 cubed over 2x plus 5 to the 5th. Okay. And there you go, just an alternate form of how you may see this represented on a multiple choice answer, okay? All right, that is it for this video. In this video, we use the chain rule multiple times, one right after another, and then we also integrated the product and the quotient rule while using the chain rule as well. Give me a thumbs up if you like this video. Subscribe for more awesome math videos.